A common task in 3D graphics will be to find the vector between two arbitrary points in space. We did cover this briefly in the video on vectors, but we'll quickly review it again, and this time we'll use a spreadsheet to help us organize our calculations. So again, to review how we perform this operation, we have 2 points in space here, P1 and P2, and we have the coordinates for each of these points, right? P1 is at the coordinates 2, 1, P2 is at 3, 3. So what we are trying to find here is the vector telling us how far away P2 is from P1. So what we're trying to find here is the components of this vector. So this vector will be defined by, well, the x components, right? So P2x minus P1x. P2x minus P1x. That will give us the change in x coordinates, and as well P2y minus P1y, right? So same deal for the y components there, and that will give us the change along the y-axis. So this is the calculation we need to perform in order to get a vector from 2 points in space, and let's go ahead and perform this calculation. So I've pulled up Excel here, and we're going to find that, well, making use of a spreadsheet like this is going to prove to be quite useful for performing these sorts of calculations. So let's go ahead and define P1, and well, our coordinates for P1 were 2 on the x and 1 on the y, so I'll use these cells right beneath P1 as a column vector, essentially, and I'll just write it this way. And we also had P2, where the components were 3 and 3. And then what we can do is we can say that the vector from P1 to P2, and I'm just gonna include this additional information here just to make it clear what vector v we are calculating. So this vector, its coordinates are going to be, and then let's perform a calculation here for the x coordinates. So this cell is going to be equal to the x coordinates of P2 minus P1. All right, and we'll just go ahead and hit enter there and get Excel to do the calculation for us. And as well here for the y coordinates, we'll do the same thing. Actually, let's just drag that down. We'll get this calculation to automatically propagate to the next row here. We can always go back and just check that the correct cells are being used for that calculation, right? So this one takes C4 minus B4, right? So that's P2y minus P1y, and goes ahead and gives us our correct answer of 1, 2. So this vector here, put this up here, and say that this vector is equal to 1, 2. And again, recall that this resulting vector represents the displacement from origin to its destination point. So again, visually, we have to think of this new vector as sitting at origin, all right, at 0, 0, or in standard position. But the point here is that this vector does cover the distance spanned between P1 and P2. And one last thing back here in Excel, let's add a third dimension to our vector calculation, because most of what we do in this course will, of course, be in 3 dimensions. So how about for starters, we just add a z component on here to each of these points, and just start by setting it to 0. And again, let's just propagate this calculation down to the z component here, and this will work just fine. Let's insert a new row here. Let's merge these cells together, and call this vector from arbitrary points. Vector from arbitrary points. All right, and we might as well keep this. Let's hang on to this spreadsheet and keep working on this. We'll add our different calculations to this spreadsheet so that we can use this as a tool to check our work moving forward. We can use it to check various calculations. Maybe if we're writing something in Python inside of Maya, doing some linear algebra calculations, we can test those calculations using this spreadsheet to make sure we're doing everything correctly.